Okay, bums. I said that's how I was gonna. Oh, you got your hair back. Okay. Um, bums that did not watch these videos. Maybe you didn't have to watch. Sorry, it's not showing the same thing on class what we see on the internet. Didn't watch any of these. So I guess you still have a chance if you're a little cloudy about what we're doing here. I am gonna what's it called when even though I shouldn't do this because you should have already watched it. I'm gonna enable your lack of doing what you're supposed to do by actually showing you this video, but I'm not gonna show it on my video, a video of a video. Because this is somebody else's, so I'm going to pause this. We're going to go through this little 8-minute video on the difference between using Z and T, and then I'll talk about it. Our notes are short, so this should be fine. Okay, so we watched this video. Again, I was going to take it. There's your pictures, illegal Mr. Samulus. All right, so we watched this when to use Z and T, and now it's just formula usage time. Okay, so from the video, we learned that degrees of freedom actually is related to when we divided to find a standard deviation of a sample. We divided by n minus 1. It's related. Okay. Um, so what we're going to find out is this is when the population standard deviation is unknown. All right, and when we talk about the test, we're kind of looking through it. What we need to make sure we see, and we're going to do this, is that we understand the population standard deviation is not given. So you have to find a sample standard deviation, or it says the sample standard deviation is given. Then you must go to the formula that we're going to talk about today. So I know that's maybe a little tough, but we showed that video and told you what we need to do. So now it's time to look at your chart, which I don't have a printout for the movie here. So we have to get our T chart now, and we look at that, and we can see what's that. Okay, T chart. Actually, on the left column it says DF. What does DF stand for? Degrees of freedom. Okay, so now how do we find our T numbers? We look at the confidence level that we're looking for, and that is down at the bottom. And that's at the bottom. That's a row on the bottom. Okay, top row, actually bottom row we could look at. And that's labeled by the letter C. And then we look at the right column, the degrees of freedom. N, right? Degrees of freedom. I'm just going to put DF. Okay, so here's what we need to be able to do, and then we'll talk about how to do a confidence interval, which was on the formula was given on our previous video. I want a confidence level of 99%. So you look down at 99%, and then there are 12 trials, but what does that mean the degrees of freedom are then? 11. So now we look at 11 on the top, in the left, and you go 11 across and match it up with 99%. What is our T value? What do you see for that when you match those up? 3.106. All right. And now what you're going to find out in this formula is Z from yesterday's formula is replaced with that T value. In the previous video that I showed, sort of explained why it actually did, and I'm not saying you're going to quite fully understand it, but at least it's something. So for a C value of 80%, a confidence level of 80%, with 26 trials, the degrees of freedom are actually 25, n minus 1. You go to the left, look at 25, and go all the way across to where 80% lines up with that. And what do you end up with for a value? 1.316. So the ability to, use the chart appropriately and understand when we have this formula, you don't use 26, you use 26 minus 1 as kind of explained in that previous video. All right, so to calculate a confidence interval when the population standard deviation is not known, you have to go to the sample standard deviation, and instead of using a Z value, you need to use the appropriate T value. Okay, that's the whole idea, and kind of the video explains that. So it is, like yesterday, the sample mean, And then to find the confidence interval, plus or minus, remember this is the margin of error, all right? But not knowing the population, total population standard deviation, you can't use z, you got to find these t values like we just did in the previous example, and then multiply that by, you don't have the population standard deviation, so you have to find the sample standard deviation denoted by the letter S. Now again, when we're talking about the exam, you're going to get a formula sheet. Okay, the formulas are not going to be labeled though. So the only thing you have to figure out is, yesterday's formula had sigma, and you just need to know that sigma stands for total population standard deviation. So that's when I use that formula. S is sample standard deviation, and then that's when I use a T. So there should be no problem knowing the difference between using these two formulas from the previous 2 days, or this day and yesterday. All right, so here's where this actually word problem is not worded well. Okay, and we will make sure that it is worded well on the test, and I will add a word that will be on the test. Okay, and the word that's missing is sample. And where does it belong as you read this? Where does the word sample belong? Before what word? Standard. So this is a poorly worded question, and I am admitting that right now. Because yesterday I think we had a similar worded question, and because we were saying we know the population standard deviation, maybe the word population wasn't in notes yesterday. I think it was. So if the word with a population standard deviation of 10 degrees, you would use yesterday's formula. Do you get it? Okay, so this says sample standard deviation. All right, and then you go from there. Okay, so you randomly select 16 diners and find that the average temperature of coffee is 162 degrees. Average temperature. That is your population. I'm sorry, sample mean. My bad, dogs. Okay, you tested 16 diners. So what's your degrees of freedom? Where they come up with that term, by the way, I don't know. But what's your degrees of freedom then? 15, and then that's what we're going to use for looking at our charts. All right, construct a 95% confidence interval. Now, you go to 95% and go 15, go across and match those two up, and what is our t value? What do we get? What's our t value? Look at your chart. I got it. 2.131. So that's the first thing you got to do. You got to find that, and then you look, and we got everything figured out. Now, don't confuse the two. The degrees of freedom is just how you look at your chart. You still had 16 trials, so 16 will still go in this formula here. So don't mess that up. Okay, so your standard deviation. I'm sorry, your population mean, plus or minus. T-value multiplier, 2.131 times. All right, the sample standard deviation is given in this as 10 degrees, right? And then the square root of, remember what I said, the degrees of freedom are only for the chart. You do put the number of trials you actually did back in the formula. There were 16 trials to try to figure this out. So this is 162 plus or minus, and then I'll do the calculations, which are already done on my piece of paper here. 5.33 is what you get out of this. All right, and then when you add 5.33 and subtract 5.33, just looking at my previously done, so I don't have to worry about calculating this. Really shouldn't be here for that. What variable do I put in the middle? What variable do I put in the middle? Mu. What we're trying to do is find out something about the population mean. All right, and then we could say something about that when we write our sentence. I'm not going to write it, I'm just going to say it. Just for time purposes. So how do we interpret the results? We say we are 95% confident that the true mean temperature mu, that's a parameter, all right, of all coffee sold in the world in diners is between 156.67 and 167.33. We're confident 95% that that's the case. We have some people making some faces. I got to find out if we have questions. Okay, now, excuse me. Okay, how many people have an Inspire? Raise your hand. Inspire. Did I not help you yesterday with your calculator? Too much? Okay, are you okay? Maybe we did work through some stuff. Okay, this is one where they give you data. And then let's talk about the difference between this question and when I gave you the data in yesterday's question, you know, oh, like number 13 in the homework. Because number 13 in the homework gave, even though they had data for you, how many values were there if you did number 13? I don't know. I didn't do it. Okay, wasn't it like 32 of them, right? All right, but then they still gave you, we happen to know the population standard deviation is this, right? So they still gave you the population standard deviation so we could use yesterday's stuff. So look at this. You randomly select 9 days and count the number of water bottles Miss McGrath had. Wow, 9 one day? Anyway. The results are listed below. Construct a 95% confidence interval for the mean number of water bottles she has per day. How is this different than number 13? There's no other information. They don't give what the total population, like what she does every single day of her whole life, what's the standard deviation of her drinking water bottles forever. All right, so that information isn't given. So now we're going to do what we did yesterday. I would love to open up the Inspire, but it drives me nuts on my computer. It just is really small and it's hard to see things. So what we're going to do, Inspires, you open up a new document, right? And then you select List and Spreadsheets. Us, we go to, I'm not going to do what I did yesterday. I hit Stats, Edit, and then L1. I need to make sure I have L1. If you don't have L1 listed up there, then go over to this blank spot and hit second one, and then press enter. Then L1 will come back. But I need to clear this list. Don't delete it. If you delete it, just L1 disappears, and then you're doomed. All right, and then we're going to type in the numbers. I love doing this online. 9, 5, 6, 7, 2, 3, 4, 6. Hey, let's watch that video where that guy just says numbers. All right, anyway. Second quit. Now, for the Inspires, and it automatically saves those numbers in that list. They don't disappear. For the Inspires, after you're done putting the numbers in the list, stay there. Stay there. Don't get rid of that chart. And then you hit Menu, and then I think it's Statistics or something like that. And then right away you see one variable Statistics. And then it asks you, are you listening? How many people have an Inspire? It asks you, is your list in A bracket bracket? And hopefully you put it in column A. And then it goes down to the bottom. It says it'll put your answer in B bracket bracket. Do you see that on your screen? Then you can press enter and you'll be done. We will hit stats and calculate, and we will calculate one variable statistics. Now, at this point, 84s and 83s have a little different look here. This is an upgraded 84. Just make sure that the list is an L1. Okay, I did put it in L1, and then all you have to do is calculate. I think for an unupgraded, you don't get that thing. I think you still have to press enter. Okay, just press enter, and then you go. Okay, so here we go. We got our information. All right, and unfortunately, I think I have to minimize this so that, oop, that's pretty small. There's my pictures of my family on the internet. They can sue me now. Look at that dog, though. Isn't that cute? Anyway. Okay, so what's that first thing? X with a line above it. What is that? What is that, everybody? 4.8. I suppose we could round to the hundredth. That is our mean. Okay, now you got to be careful here. And I don't know how. There must be something later. But what is that? What does that symbol mean right there? What does that mean? That is the standard deviation of the what? Population. How would they know that? All right, and that's not the one we want. We want the one above that. See that S? What does that stand for? That is the sample standard deviation, and that's what we want to write. So we got to be careful on that. And then I don't know, how far should I take this out? I guess I'll take it out to 3 decimal places. 369. The more decimal places you take it out, the more accurate it is, I guess. Okay, remember we wanted a confidence interval of 95%. And again, I just want to make sure I have all the data that I need here. What's the degrees of freedom? Well, how many trials are there? How many trials are there? 9. So what's our degrees of freedom? 8. So now we look at 95 on the bottom and then 8 on the left, and we cross-reference those two. And what do we get for a t-value? What do we get for a t-value? 2.306 verified. Okay, and now I can zoom this back out. So using the calculator real quick, because believe me, you remember how to find standard deviation? I'd have to find the mean, and then I'd have to take all these x values minus the mean. I'd have to square it, then I'd have to add them all up, right? Remember doing all that? And then divide them by n minus 1. And then it's the square root of that little thing. Well, that just did all that for you in a flash. So you have to see that there's value there. So I already tested you how to find standard deviation. Now we're going to use the calculator to do more complicated stuff. Okay, so the formula, x with a line, plus or minus the t number times the sample standard deviation divided by the square root of n. Now we can plug in all these numbers. 4.89 plus or minus 2.306 times, what time is it, everybody? 2.369, the sample standard deviation, divided by the square root of, you do throw in n there, 9 trials. Okay, and then you go from there. So this is 4.89 plus or minus, calculations done for you, 1.82. Minus 1.82, you get 3.07, I hope. Mu. And then 4.89 plus 1.82 is 6.71. Now, maybe I will write this because I was lazy on the last one. How do you interpret the results? We are 95% confident that the true mean, better write over here, and I'm going to add to this, true mean of Mrs. McGrath's life of drinking water bottles daily, forever, her whole life, maybe of being a teacher, let's say, because that's when she'd drink water bottles during the day. Mrs. McGrath, the true mean of Mrs. McGrath's total water bottles, the mean would be between 3.07 and 6.71 water bottles. I'm running out of space, so I'm just going to do that. All right, we're done. Questions we can ask offline.